Looks like we're live. Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. How about that? But you didn't expect that shit to happen. Let's make a little bit of an announcement and officially start the stream as usual, live on Twitch. And what are we doing today on Twitch.television website? Today we're doing own Manim style, but in C and with Raylib, right? So my own Manim style library with C and Raylib. So essentially, for those who doesn't know, I forgot to actually like ping and stuff like that. Jesus fucking Christ, twitch.tv/Zoding, right? So, and ping everyone who's interested in being pinged. I wonder if it will actually, it actually highlighted it as it's pinged. So I suppose now everyone is pinged. So everything is Gucci, everything is Tamaguchi. So, right. Essentially, if you heard about the channel 3 Blue 1 Brown, right, you probably know about his animation engine thingy, which is called Manim, right? And essentially, I want to have kind of similar thing for my YouTube channel, right? So for making animations about programming concepts and stuff like that. So, and since I'm a programmer, right, it only makes sense. To actually make it myself from scratch, right? So not necessarily from scratch, we're going to be using Raylib, but Raylib is going to be needed for just putting some shapes on the screen and stuff like that. So an idea is going to be that I'm going to reuse some of the technology that I developed in Visualizer, right? So you probably know about these things, Visualizer. So essentially, one of the things we'll need from Visualizer is an ability to render videos with FFmpeg. Right, so I'm gonna put the link to Visualizer in here. So we're gonna strip off this, we're gonna steal this ability of like rendering videos with FFmpeg from Visualizer. Right, and another thing I will probably need is an ability to hot reload our application, because you're going to be writing animations with the C code, right? So that means you need to have a sort of like a very short feedback loop, right? So essentially you modify something, you want to see that changes instantly on the screen. So because of that, we're going to steal some hot reloading technology from Visualizer as well, right? So, and essentially, I envision that framework, that engine, to be just a library that you link with, right? So each individual animation, so to speak, is going to be a library, an executable, right? An executable that links with that library, and then it has an ability to generate the final videos and stuff like that. So that's basically how I see that, and that's basically what I'm going to be going for, right, for today. So yeah, we're going to start doing all of that and we'll see how it goes. That's the plan for today, essentially. That's the plan for today. So I'm going to call it Panim, right? So because Manim is a mathematical animation engine, this one is going to be programming animation engine, right? So I think it only makes sense. So let's make maybe a little bit of a boilerplate. My name is 1-3 Blue Brown. Yeah. So it's written in Python. I don't really know how exactly it works and what kind of things it uses, right? So, but yeah, so like from how it looks like, it seems pretty straightforward to implement it, right? So I don't know, like I didn't see any particular difficulties in there, except like it has cool animations over the vectors of the fonts and stuff like that. We're probably not gonna go into there yet, but maybe at some point we're gonna have something with the vectors and animating the vector representations, SVG and stuff like that. We'll see how it goes. It also has a cool mathematic rendering with latex and shit. So I don't know how exactly it renders the latex. I suppose it just calls to latex as an external program, right? So this is something that we can try to do as well, right? So I suppose maybe it just like asks latex to generate some SVGs, then it loads those SVGs, and having a vector, it can kind of animate that based on the vector or something like that, right? So doesn't sound like something impossible to implement in C as well, right? So we'll see how it goes. We're going to start with some simple stuff, right? So we're going to start with some simple stuff. And what I'm going to be using it for, I'm going to be using it in my next video about the Turing machine language, right? So Tula, this one. It's actually beta. You're not supposed to see beta, right? So there's a public page in here with a README which explains how the language works and stuff like that. So, and the idea that I have specifically for that video is not going to be that it's fully animated videos, right? So essentially, I'm going to have animated interjections, right? So when I'm about to explain some sort of a concept, it's going to switch to a different kind of scene where I have animations which kind of like supplement my like voice-over explanations and stuff like that. But the majority of the sort of the idea is going to be conveyed my usual Sodin style, where I talk and code simultaneously. You know, the usual thing that I do in the stream, right? So this is like the focal point of the content, but sometimes there are going to be like animation interjection, right? So to explain some sort of a concept, right? So for example, like I want to explain the concept of a Turing machine. So I'm going to go into the scene where there's only animation, and there's a Turing machine which visualizes the tape, the head, and stuff like that, right? So and then once that out of the way, we go back and we start coding. We code for a little bit, then another concept that needs explanation, animation pop up, and just like stuff like that. You know what I'm talking about, right? So I know maybe it will make more sense when I actually develop that, right? So, but we'll see. Sounds like a Python or Lua bindings for such kind of library is kind of useful, probably, but they're useful for their ability to hot reload. You can hot reload C as well. Right. The only reason why you want to use scripting languages like Python and Lua is for hot reloading. You can hot reload C as well. I implemented that in Visualizer. Right. I'm not really claiming that using C for this kind of stuff is better or worse, not making any claims. I'm just saying that it is possible. And I think here I can conduct some sort of an experiment to see, right, to see if it is like, you know, at least convenient. Lukewarm reloading. Yeah. So the idea is that you basically put all of your logic into DLL, right? So you recompile DLL and you ask the main event loop to just reload that DLL, and that's it, essentially. And it's pretty much as convenient as using dynamic languages, honestly, because I use that in Visualizer, and I used it a lot for developing UI and stuff like that, and it was actually extremely convenient. Like, I would not be able to develop the UI of Visualizer without hot reloading, right? That was an essential feature to develop the UI. Right, and we're definitely going to have something like that in here too. And honestly, to be fair, I'm not a really big fan of dynamic languages. I like statically typed compiled languages, right? So for their ability to check some things, right? So don't really want to use Lua. People love Lua, right? So probably because of its syntax. I'm that kind of person that doesn't really care that much about the syntax. I really care more about the semantics of the language, right? So I don't know. We'll see. Anyways, let's go into the Panium. Right, so I'm gonna start with maybe creating some sort of a hello world. How about that? So let's go, my friend. Let's go. We're going on to an adventure. Let's go. I can't even spell world anymore. I haven't programmed in C for a while. So we probably need some sort of like a knob thing, right? So we need a knob situation in here. So let's actually bring the knob. Bring the knob. So this is the knob.h, and there we go. So this one is main, right? So I think I'm gonna still call it main because it's gonna be the executable, right? Because the actual engine is gonna be sort of like a library, right? So that kind of makes sense to me. So we're gonna have knob.c, and let's just include knob.h, right? So, and obviously it's header only library, so we have to do knob implementation. Right, so we have to define this entire thing, and we're going to... Why Emacs? Why are you highlighting this shit? Please do not highlight that. So we need to actually accept the arguments so we can enable go rebuild yourself technology from knob. Right, go, where is it? Go rebuild yourself, right? The famous go rebuild yourself technology. It automatically detects that the knob executable needs to be rebuilt. Right, so, and that's about it. All right, so we need to create maybe cmd knob, cmd, right? So what we're gonna have in here, knob cmd append, cmd. So we're gonna have just a compiler. Within the compiler, we're gonna just do main, like so, and we're going to supply this thing as an input. So that should be enough for now, but maybe right away I want to enable all of the warnings and maybe some extra warnings, so for some extra spiciness with the compiler, you know, checking. You know what I'm talking about, right? Knob cmd run synchronously, right? We're gonna run this entire thing synchronously, and if it fails, we're gonna return non-zero exit code. There we go. So that's pretty much it. So let's go ahead and just do cc noob.c, right? Let's go. And it cannot find noob.h, which is kind of bizarre to me. Is that because yeah, okay, so that makes sense, right? Apparently there is a semantical difference between the triangular brackets, right? So so I suppose the quotes are searched within the current folder. All right, so what do we have in here? CMD, it's actually Noob CMD, excuse me. Right, so this one, you don't have to pass it by a point. I don't remember how to program in C, and there we go. So we built the builder, and now we can run the builder, and it built the main application, and if we run the main application, it says hello world. Right. That's what's happening in here. That's what's happening here. Can your GCC borrow check? I don't think so. You don't need borrow checker, honestly. Just use your brain. Find a language that we can read. Yeah, exactly. So we got some subs, by the way. All right, so let's actually acknowledge the subs. Thank you so much, Eva Marco. Thank you so much for the try with the message. I forgot to make tea. That's all right. So the VODs is going to be available, so you'll always be able to then later, you know, rewind back and watch again. Sintus, thank you so much for Twitch Prime. Thank you. Really appreciate that. Manim Pog, yeah. So, but this is going to be called Panim, right? So because Manim is a mathematical animation engine, and this is the programming animation engine. So Manim is specifically designed for math. This one is designed for programming. Probably not that much different, but you get the point. Anyways, so let's actually bring the freaking Raylib in here. Let's bring the Raylib into the equation. Let's go to the Raysan, you know, repo and download some scheiße. Programming is math with extra steps. Yeah, suppose it's a discrete math. It's an applied discrete math. Astrobot, thank you so much for tier 1. So let's go and just grab some of this stuff. Linux AMD 64. Copy the address, and we're gonna just go here, wget, boom. All right, it's downloading. It downloaded. Cool. So let's unpack this thing. And within in here, we have everything we need, right? So essentially, we'll probably... So since I'm going to be hot reloading, I'm pretty sure I'm going to be essentially linking with the dynamic library, right? So that makes sense. So we're not going to be doing the static thing in here, only dynamic. And for the includes in here, so this is basically what we have. Okay, so let's create a window. I'm going to include the Raylib as usual. And we're going to init the window. Right, so it's going to be in 60 panim, right? So then while window should close while it should not close. So we're going to be doing the usual thing. Begin drawing. So I'm doing a Raylib speedrun, by the way, yet again. Every time I'm programming in C, I'm doing Raylib speedrun. Clear background, background red. And in here, we have to do close the window, right? We're closing the window. So if we try to just build this entire thing as it is, it's not going to work because it can't find Raylib, which is fine. That is fine, everyone. That is totally fine. There's nothing to worry about in here. We're going to add this thing soon. Don't even worry about that, chat. Don't even worry about that. So we're going to go in here. We're going to just find the include folder, and we're going to grab the path to the include folder. And just copy paste it in there. It's that freaking simple. You see, there was nothing to worry about. There's nothing to worry about. It's already here. All right, so what else do we have in here? So now we have to, you know, link with all of that stuff. So essentially, I have to repeat this entire thing, but for the library. So this is going to be just lib. And I wonder if you can just say L, right? But then specify only lib raylib.so. Right, and I don't know if I have to do like a position independent thingy or not position independent thingy. We'll see. Right, so let's try to rebuild this entire stuff, and it seems to be like it's, yeah, it actually linked, compiled, and stuff like that. If I take a look at LDD in here, yep, you can't easily do that, right? So it cannot find it. I think there is a concept of RPATH. Do you guys know about it? It's like a RPATH. Come on, you can do that. So essentially, it kind of bakes the path to the DLLs into the executable, so you don't have to specify it. Right, it's a disaster. Yeah, it's absolute disaster. But I mean, we're developing a thing that is not supposed to be shipped to the end non-technical user. We're developing a thing that is going to be used by a technical user who knows how to program in C and also knows how to make animations, right? Basically, I'm developing it for myself, right? I'm basically developing it for myself. So yeah, RPATH designates the runtime search path hard-coded in an executable file or library. Dynamic link loaders uses RPATH to find required libraries. Yeah, so we can use LD library path. Yeah, we can do that, but it's not convenient, and it increases the size of the command lines that I have to put in there, right? So it's a little bit easier to use RPATH, and this is exactly what I used in Visualizer, believe it or not, right? This is precisely what I used in Visualizer. If I go into the builder for Linux, I think I have, yeah, there we go. This is literally what I'm doing here. Look at that. So I just pass to the linker RPath and the path to all of the, like where all of these things are located, especially in here. Look at that. I'm passing the path to the Raylib. So this is probably what we want in here, honestly. This is probably what we want. So I'm gonna go into the noob.c. and we're passing it to the main compilation thingy. So I'm gonna like put it somewhere here. Noob cmd append cmd like so, and it is going to be essentially, yeah, it's going to be essentially in here like so. Right, so now let's try to rerun this entire thing, and if I take a look at the final executable, as you can see, it found it, right? So it now points precisely at that entire thing. I don't have to use LD library path. And again, I'm not going to be shipping that executable to end user and non-technical user. Like these kind of executables are just for your computer, right? The sort of like the end product is going to be a library with which you're sort of linking, right? Not the executable. Executable is your own custom thing, right? Essentially, that's the idea, at least. If I try to run main now, as you can see, it's working. So we can even check what would have happened without our path, right? So we can check what's going to happen. Right, so we're going to restart it, then we're going to try to run main. As you can see, it cannot load the Raylib, but it literally cannot find it. Cannot open shared object, no such file or directory. So that our path is important, right? So if you never heard about our path, so now you know. Have you tried Skia before? I've heard that word before. I have no idea what that is, honestly. I've heard it on, I think, on Twitter, and I think I've seen some projects using Skia. Is this some sort of like a UI framework? Is that what it is? Like, I don't know what it is. So Skia is famously difficult to build from source. Why would it use it then? Right? Why would I use it then if it's difficult to build? Like it's like an opposite of what I stand for. So Google 2D rendering engine Skia equals the Chrome renderer. I think I saw that when I was trying to build OBS, because OBS uses Skia for like browser support or whatever the fuck it is. I don't really know. Every Google project is famously difficult to build from source. Yeah, and I'm pretty sure they're freaking doing that intentionally, right? So, so essentially this is like an open source, but it's not open source. You can't build it. You have the source code, but you can't fucking build it. It's kind of genius, actually. Go is kind of a different story. It feels like Go was developed by a completely isolated department of Google, somehow, that has nothing to do with the Google itself, because like it feels like the usual Google shittiness is not enforced on Go specifically, right? Maybe because they care about this language too much. I don't fucking know. Maybe because you know, Rob Pike and Ken Thompson work on this language, and if you start enforcing Google shittiness on that department, both of these people will instantly leave, right? I can see that. This is probably the only reason why they don't enforce the Google shittiness on that department. So yeah, but the everything else is just like, yeah, you can feel the Google shittiness in there. The Plan 9 energy, yeah. So anyway, Yesu. Now I know what is Skia. Now I care about it even less. Thank you so much for telling me what it is. I didn't care about it before because I didn't know what it is. Now I know what it is, and now I don't care about it even more. Thank you so much. So very cool. So what we need to do in here, we need to actually separate our logic into like a plugin, similar to Visualizer and stuff like that, right? So in the Visualizer, we have, yeah, we literally have a plugin. So let's actually go there. src, so plug.h. Yeah, there we go. So we even use X macros in here. Look at that. We're being fancy and shit. So essentially, it denotes like a bunch of methods that are going to be exported by the DLL of the plug, right? So they're going to be exported by the DLL of the plug. To be fair, okay, here's the thing. The only reason why I used the X macro in here is because I needed to switch between the modes of static linking and dynamic linking, right? So what I'm thinking is that in this specific framework, I'm only going to be linking dynamically because I need like hot reloading, right? So I don't need static linking in here. Because of that, I don't really need all of that stuff in here, right? I don't need to sort of abstract away how exactly those functions are sort of processed, right? So whether they're going to be statically linked or dynamically linked and stuff like that. So it literally doesn't matter. It literally doesn't matter for me. So yeah, let's see how we can even approach this entire stuff. So I'm going to create a plug .h, and this is where we're going to have an interface, right? So this is going to be, oh, I can't do that. So let's put inclusion guard. If not def plug.h, we're going to define this entire thing, and we're going to do and if like so. So what kind of things we need in here? We need a thing that initializes the plug. Right, we need the thing that initializes the plug. So let me open the visualizer one and see what kind of stuff we have in here. So we have pre-reload, post-reload, right? So I didn't really know if I really need them that much, but maybe I do need them a little bit. Maybe I do need them a little bit. So this one is rather interesting. So usually plugin, the DLL plugin allocates a little bit of memory to sort of keep its state. Right, it allocates a little bit of memory to keep its state. Right before reloading the plugin has an opportunity to return to the pointer to its state, so then it can be carried over to the new version of the plugin in here, like so. Right, so you see what's going on here? All right, when you do plug init, the plugin, the DLL, will allocate a chunk of code where it's going to store its entire state. When you are about to reload the thing, we're going to be calling this thing to the plugin, notifying it, I'm about to reload you. This thing will be so fucking scared of being reloaded, it will return you the pointer to the state it's allocated. You're supposed to save that thing, then you kill that fucking DLL, right, while preserving its state that it allocated. You load a new DLL and you pass that old state, the state of the old DLL, to the new one. So that's how we preserve the state of that DLL. Right, and it actually works. In Visualize it works. So the only way it's not going to work is when the schema of the state changes, right? But it's actually kind of a rare occasion, right? So if the schema of the data changes, that means you're making like very much radical changes, and you probably want to reload the entire thing anyway. Right, so usually it's fine when you're just modifying some colors, right? So quite often I need hot reloading to like tweak some little small things without resetting the entire state, and in that case the schema of the state of the plugin doesn't really change at all, only some constants change. So in that case it's totally fine. You see what I'm talking about? Right, so it's actually kind of cool. So we do need this kind of thing, I think, right? So pre-reload, post-reload, and it carries the state between the DLLs and stuff like that. Is it possible to detect the state change? Of course it is possible. You just have to put a little bit more effort into how you organize the hot reloading, right? So the more effort you put, the cooler it may become, right? So maybe along with some, state, we can also keep track of the version of the state, right? So, and then the post reload can detect that the state is of previous version, and it can apply migrations, right? Similar to SQL migrations, but to the state in the memory. Why not? Right, we can just like use the same trick that databases uses, people who like develop databases and stuff like that. So we can do something like that. Right, I was actually theorizing on how to do that. I never implemented that. It would be kind of interesting to do that, but we're not going to be doing it in here because it's kind of an overkill for what we're doing here, right? Again, if the schema of the data changed too much, you can just reload the entire thing anyway. So you're doing something like radical at this point, and you want to like restart anyway. Right, you want to restart anyway. That's my, how to say that, rationale for doing it the way I do. So it's sort of like a, you know, trade-off, like how much power you want to have. Can you change the schema as well by using the word magic? Yeah, you can do pretty much anything. So anyway, so we're not going to be doing that because it's like a lot of effort and we're not going to get that much of a benefit anyway. Right. So we also have additional, like in Visualizer, we have additional things for loading resources, free resources. I don't think we need it for now. Maybe in the future we're going to need that, but not for now. So plug update is an interesting one. It's the one that is going to be called on each frame. And it's the one that basically renders the frame using Raylib and stuff like that. So this is the only things we need in here. I think that's basically the only things that we need in here. And essentially what I want to do, I want to define those things as variables, right? I want to define those things as variables. And I think this is what I can do in here. Right, so I'm going to say something like this. And if I understand the syntax of C correctly, if you do something like this defines each individual function in here as a variable, which contains a pointer to that function. So then later you can do something like this. If I'm not mistaken, I keep forgetting the syntax of function pointers, but I think that's basically how we do that. Right, and essentially how we're going to be doing that, we're going to be using DL open, right? I think LD open and LD find and whatever the fuck it is, right? To sort of populate these things, right? So we're going to be dynamically loading it ourselves. Okay, so let me actually try to rebuild this entire thing. Maybe I'm going to actually go ahead and just include this entire stuff. So this is going to be plug.h. This is plug.h, and I just want to check for sanity, right? So does it compile correctly? Okay, so it does in fact compile correctly. So if I remove this pointer, there we go, right? So function is initialized like a variable. There we go. So this is a very interesting thing. So this is a quirk of the syntax of C. This is function declaration. I already talked about it in one of my videos on YouTube, right? So this is a function declaration. This is a variable declaration. This is a function. This is a variable. Yeah, and since it's a variable declaration, it's a variable that contains a pointer to the function of this type. You can initialize it with null like that. Don't freaking ask me why. It's just C. It's just fucking C. Right. It's an old, weird language. It's a weird, old language, right? So, unfortunately, we haven't come up with anything better, but I mean, it's kind of impossible at this point. C has the stupidest syntax of a very well-designed language. Yeah, it's kind of bizarre, honestly. It's kind of bizarre. So, Rust has unreadable syntax, but it at least makes sense. Some of the syntax in C sometimes doesn't even fucking make any sense. Right, but it is readable to some extent, right? Unless you need to use cdecal. So, and can I call the function with that pointer variable? You can try, sure. We can do plug init, like so, but it's going to segfault, at least right now. Right, if we try to do that, as you can see, so I successfully called it, and it's a completely valid thing to do because I have like shit ton of warnings enabled, right? If I was doing something wrong, I think compiler would have told me right away. So that means I'm probably doing something right. And then if you try to run this entire thing, it's going to segfault, right? Because you're trying to call a function that points to null. You can't do that, right? So you can't do that. First thing we need to do, we need to pre-populate all of these functions in here. How we're going to be pre-populating them? We need to load the DLL. First of all, we need to compile this plugin as a separate DLL. So let's actually quickly do that. So we need to have a plug C, right? So, and I'm going to include, I think I'm not going to even include that stuff, right? So I need to just define all of these functions in here. And if I'm going to include this header, that means they're going to actually collide with the function definition. So I'm not going to include plug h. Right, so now we actually have to implement all of these functions. I wonder if you can use a little bit of an Emacs magic, if you know what I'm talking about. Meine Freunde, just a tiny bit of Emacs magic. A boom. Look at that. A boom. That's not bad. That's a pretty cool Emacs magic, not gonna lie. So now I can do some shit like this. Yo, look at that. That is absolutely epic, my friend. So in here, I'm supposed to return like null, and in here we just do state, right? And essentially, like we can try to do this state thingy right away, right? And by the way, I think this one has to be denoted that it doesn't accept any parameters, just in case. Right. So here, let's define like a structure, which I'm gonna call plug, right? So it's a state of the plugin. So, and in here, what we're gonna store, I don't really know, maybe we're not gonna store anything, but it would be nice to just have something, because I think empty structs are not allowed per se. We can store some color in here. So we also probably want to include Raylib, right? So we're definitely gonna be using Raylib. So maybe background color, right? So this is a background color. And in here, we're gonna also have a, a static global variable that stores the pointer to that plug, right? So this is gonna be something like, initially it's null. So our engine, so to speak, is going to call plug init, which will effectively allocate this entire thing. So we're going to allocate size of plug. Maybe I'm going to even do something like this, right? So if I change the type of the plug, I don't have to change anything in here, so which is rather convenient. And also let's assert that p is not equal to null, right? So this entire thing didn't fail. Okay, so then when we are about to get unloaded, we're going to return the state of our plugin, and when we just load it, we're going to restore that state back. That's it. So that's about it. So within the plug update, we're going to be calling begin drawing, right, then end drawing. And what we can do in here, we can clear background, and we can essentially use the, I don't know, the background color in the state. So who said we can't do that? Right? So this is a basic, like a plugin system. This is a basic plugin system. Right, so, and I think we need to now build the plugin as a separate DLL. So let's actually see how we can do that. So can I factor out this entire thing somehow? Can I factor out? So let me see. Build main, right? And since this thing kind of allocates the memory, and I want to reuse the same CMD over and over again, I think it makes sense for me to actually kind of accept this entire thing by a pointer. All right, and in here, before try to use anything, I'm going to just do count equal to 0. Right, so let's go and just copy paste, like literally move this entire thing in here. Interestingly, right, so this thing may fail. Because of that, maybe it makes sense to propagate the error a little bit up. Just propagate the error a little bit up, like so. And in here we can do some stuff. If build main cmd, if not build, right, so we're gonna just return 1. Cool. So we have a separate thing in here, and obviously here we don't have to pass it by a pointer because it's already a pointer, but here we have to actually kind of dereference it, which is a little bit inconvenient, but that's fine. So what I want to have in here, I want to have like a separate thing, which is going to be build plug, right? So that's what we're going to have in here. So it's going to be build plug noob cmd, right? So, and we're going to clean up. So it's kind of cool, like when you just write in like a simple hello world, using Noob doesn't make any sense and it feels like an overkill. As soon as your program becomes more and more complicated, it starts to make a lot of sense. Like it's actually kind of convenient to have like a proper language to build your project. It's kind of insane, right? It's not obvious that this is what you want. This is what you want. And it's kind of like the point of Jai as well, right? So because in Jai, you kind of do a similar thing, right? You're using the same language to build the project in that language, right? So you would literally do this kind of stuff in Jai too, right? Which is super cool. Anyways, so we can even factor out some of this stuff, right? So I don't know, we can basically have a function which is cc, right, and it will just accept this entire stuff, like so. And we can move all of the common things in here to that function, right? So essentially like this. So this is going to be cc cmd, right? So, and I know that this is kind of stuff I want like everywhere, right? So for all of my commands, like let's just put it in here. So that makes sense, right? So, and then I can do something like this, right? So it's like a common place where I can modify all of that stuff. All right, so, and in here, what am I doing is probably, I want to build this entire thing as a library, but I'm not really sure how to do that. I think I did that in Visualizer. Let me just check how I did that in Visualizer. So plug.so, right, when I'm building this thing, I'm just like directly saying O, plug.so, and I also add these kind of flags, right? So I say generate position independent code and make the library shared, right? So this actually makes sense. Maybe I want to like basically yoink these two things in here and put them somewhere here. That makes a lot of sense to me. All right, so this is going to be shared. This is going to be libplug.so, and also we need to do something else, honestly. So this one is not needed. Also, we need to do something else. So yeah, we're linking with the usual thing, plus we're linking with LM, LD, and so on and so forth. But in the main file, I don't remember, do we link with anything? Yeah, we actually kind of do, so that's fine. Anyways, so let's just copy paste this entire stuff, and maybe factoring that stuff out would be actually also a good idea. Right, so maybe it's going to be like libs, noob, cmd. Yeah, that's a very cool idea. Maybe it's going to bite me in the ass in the future, but that's fine. I'm kind of good used to that. I even kind of enjoy that. Forget everything was said. So, right. So what do we have in here? We're going to do libs, cmd. Right, so yeah, so it's sort of like a prelude and basically postlude. What's the opposite of prelude? What's the opposite of prelude? I don't really know. I don't remember. Chat, I don't speak English. Can some English speakers help me in the chat? Right, so you have a prelude, epilogue. Yeah, thank you so much. Right, so this is sort of like a prelude, and this is the epilogue. Right, thank you. It's pretty cool. And between them, you have like this custom stuff. Makes sense. Make a lot of sense. By the way, maybe it also makes sense for me to put GDB to add debug information and stuff. Right, so anyways, let's go ahead and just run this entire thing and see how it fails. It failed fucking miserably. Fucking miserably, mate. Absolutely fucking miserably, because I never really called anything in here. Right, so I forgot to like literally put this stuff in here. Okay, so let's go ahead and do that. And that worked. That fucking worked. That fucking worked, mate. Easy peasy, lemon fucking squeezy. So we have you know, lib plug. We have main that knows nothing about it. So now we have to kind of load this entire thing. Right. So hi Turing, could you please explain what CMD append and how it works? We can take a look at the source code. Right, so as I always say, the best documentation is the source code. Let's take a fucking look at it. Okay, so where is it defined? So it's defined in noob.h, CMD append. Right, noob CMD append. So how does it work? So yeah. Motherfuckers do be saying like source code is the best documentation and then pull up this shit. Well, I mean, I fully understand this code, by the way, but it's just like, so fucking funny. Anyways, like, again, I fully understand this code. It's just like I'm thinking how I'm going to be explaining all that stuff. So, essentially, what do we have in here? So, this entire thing obviously accepts CMD and variadic amount of arguments. Like, essentially, you can put whatever amount of arguments you want in here. It will all accept it, and it will substitute all of these arguments in here. Right? It will substitute all of them in here, like so. So we actually use this, you know, variadic argument in two places, which is kind of sus, but I mean, that's probably fine. So anyway, let's take a look at each individual argument. So we're internally in Noob CMD append, we're calling Noob DA append many with actually 3 arguments. These are 3 very chunky arguments, right? So that's what they are. Okay. So the first argument is, you know, pretty understandable. So this is essentially this thing, we just forward this entire stuff. Then here's an interesting thing. We are constructing an array of strings. So this is a C string, and that says it's an array of C strings, right? And this is a syntax where you just construct such array in place, right? So essentially, if you have something like this, foo, bar, buzz, and so on and so forth, it constructs an array of strings in place as a literal. It's a special sort of like a syntax of that. So since VI args like expanded to the arguments that you put after CMD, it will construct an array of strings out of those arguments like this and would pass it as a second argument. So that's what it will do. All right. So, and what is this monstrosity? If you look carefully at this monstrosity, you will notice that this thing is actually part of the second monstrosity, right? You may notice that. So what we're doing, we're here taking the size of this array in bytes. We're taking the size of this array in bytes. Then we divide by the size of the string. Effectively, this entire monstrosity simply computes the amount of arguments in this monstrosity. That's everything there is to it, right? So essentially this thing forwards that CMD, then takes all of the arguments that you put in here, which are strings, constructs an array out of them and passes that array in there, and then computes the size of that array and passes that as a third argument. So the structure, the thing where you want to add those things, the array of the things that you want to add, and the amount of elements that you want to add. So again, the source code is the best documentation. You just have to calm down, take a deep breath, and carefully analyze what you're looking at. Never get scared by the code. Remember, code is scared of you more than you scared of code. Just split it into parts and analyze each individual part, and it will make sense. Okay, so we understand what this code does. So we can now go and see what DI append does, right? So what DI append does. Right, so let me see. So where is the implementation? Okay. Anyway, so essentially in my code, like there is a notion of dynamic array, right? There is a notion of dynamic array, and dynamic array is any structure, like literally any structure that has 3 fields. Right, so we're gonna call DA. DA stands for a dynamic array. So essentially the first field is items. The second field is count, right, which is usually size t, and the second one is capacity. So essentially, items points at the beginning of the data of the array. So this is where all of the elements are located. Count is how many elements you have in that array, and capacity how many elements you actually allocated with Raylib, right? Capacity can be bigger than count because we usually pre-allocate more things than we actually use in count. So with this macro, we sort of abstracting away from the types of items. Right, so we are simply abstracting away. So essentially what this macro does, it takes dynamic array, which is a structure that has at least these 3 fields, and it appends all of these elements into that dynamic array, and like with this amount of elements, right? So this is the pointer to the elements, this is how many elements you want to append, and it just appends all of these things into this structure, also allocating enough capacity if the dynamic array is not big enough to fit all of that stuff in there. That's what it is. That's what it is. So what that means, Noob CMD append appends a few elements. Let's actually take a look at this kind of thing. So Noob append. Okay, so this is apparently a dynamic array. So Noob CMD is a dynamic array, and we're appending a bunch of things, a bunch of strings into that dynamic array. So that means CMD is a dynamic array of strings. We can take a look at the definition of Noob CMD. Noob CMD. There we go. And it is a dynamic array of string. Look at that. It's literally that. It has items, it has count, it has capacity, and so on and so forth. So it's a dynamic array of strings, and we're appending strings into that dynamic array. So then we have functions nopcmd run synchronously, which accepts that dynamic array of strings and literally creates a child process that executes that command. So what this entire thing does, it simply constructs a command line in C. That's it. That's it. That's it. It's that fucking simple. Does it make sense now? Does it make sense? So it's kind of equivalent to command in Rust. If you ever programmed with Rust up doc path. Oh my god, path like this. Oh, I did some fucky work here. Oh shit, I don't have a Rust up in here. Okay, so Rust API command. Right, so there's a special structure, yeah, there we go, in the process package, which is command. And as you can see here, you construct a command line and you just run it. So this is basically that, but implemented in C. That's it. Simple. Easy peasy, lemon squeeze. Anyways, so yeah. And I'm just using C as a bash. Right, I'm just using C as bash. Okay, so what we're doing in here, we're just building all of that stuff. So, okay, enough of the talk, and let's go ahead and continue the development. So I'm gonna try to rebuild this entire thing. Okay, so I didn't break anything within Noob.h, which is good. So we have a lib plug, and now we need to try to load it up. How are we gonna be loading it up? I think we're gonna be loading it with LD. Goddamn, man doesn't work. What the fuck, bro? Okay, it works here. LD open. Is it LD open? DL open. Yeah, this is what we need. So it allows us to actually load the dynamic library, right? So we probably need to first include this special thing with the name deal, right? So that's a very common name in POSIX. It's a very famous deal function, actually library. So let's include that. C development be like, and let's just try to load this entire thing, right? Let's just try to load. So we're gonna be loading it from, I think we're gonna assume that we loading it from the current folder, right? So I think we'll have to update our path because otherwise it won't be able to find it, but we'll see. So we're gonna solve problem as we encounter them, right? So in here, so what about the flags? What kind of flags we're supposed to use in here? I think, let me just search for them. RTL lazy, so that means it's not going to load the symbols unless we try to use them. I think we need to do RTLD now, right? So we're gonna load everything right away. So in here, we basically just loaded the handle, right? So, and as far as I know, if this entire thing returned null, that means we didn't manage to load it at all. Right, we didn't manage to load it at all, but don't quite remember. So let me actually see return. So on success, it returns blah, blah, blah. Errors from these functions can be, so returns on success, DL close returns 0. On error, it returns non-zero value. Oh, it's DL close. DL open returns non-null. On error, returns null. Errors from these functions can be diagnosed with DL error. Okay, that's actually cool. So we're gonna do something like, so const char lib plug path, and we're gonna do something like this, lib plug path. There we go. Right. So it allows us to do something like error could not load as because of as. Right, so, and we couldn't open lib plug path. And can we use DL error to actually get the description of what the fuck has happened? DL error, let me see. Oh, it literally returns a string. What the fuck? What the fuck? A convenient error reporting in C? What the hell is going on? All right, please give me that. Thank you. That's very cool. Okay, so let's actually try to rebuild this entire stuff. Does it compile? It doesn't compile because of the code semicolon. That's fine. Let's try to run this entire thing and could not load libplug so. Libplug so cannot open. Could not load libplug so. Libplug so cannot open shared object file. No such file or direct. That's a little bit redundant. Okay, so I suppose they already include all of the necessary information that I want to report here anyway. Right, so let me go ahead and maybe remove some of that stuff. Right, so some of the stuff is kind of redundant, if you know what I mean. It's kind of redundant. Right, so maybe I'm gonna even do something like Noob and then main. Look at that. So it cannot load this entire stuff, right? Because it can't find that. I wonder if I can just like directly say load this thing. Will it work? It worked, right? So, but it couldn't. We can actually like directly try to load this thing up. Right, or we can modify RPATH, right? So essentially one of the things we can say, just add another RPATH to the executable. Right, so so we already said use this RPath, and the second thing we can say use you know, this RPath, right? So we can always say that, and that works as well, right? So now RPath automatically tries to search within the current folder, and it works. It does in fact work. It does in fact work. So the next thing we want to do, we want to actually kind of load up all of the functions, all of these functions that we listed in here, right? So plug init, preload, post reload, update, and so on and so forth. We can do that. We can do that by using, I think, dlsim or something like that. Let me actually find that. I think it's called dlsim. Yeah, there we go. So you're supposed to provide the handle version. Oh, it's a dlvsim. Okay, so we only need this one. So you provide the handle that you loaded with dl open, and you provide the name of the symbol. You provide the name of the symbol. Very easy. Okay, so let me see. So now we're gonna do dlsim lib plug, and the first thing we want to actually load is plug init, right? So, and we're gonna assign it to plug init, which is the variable that we defined in plug.h, this one. So we automatically assigning this entire thing, right? So we probably also want to check that this thing is actually not equal null, right? So because I think it may be equal to null, right? Let me see. So when for return, on success, this function return address associated with the symbol. On failure, returns null, and you have to use dl error, blah, 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 blah. Okay, that's cool. So let's do the following thing. Right, so we reload this entire stuff. You can actually just like use the same code here over and over again, right? So, and in here, plug init. So this one is going to be pre-reload. Okay, so here we're going to have post reload, and here we're going to have updates. Let's go. Okay, that's pretty cool. And let's try to rebuild this entire stuff. So the cool thing is that probably what we can do is maybe say something, right? So essentially, we just successfully loaded libplug and all of the functions and stuff like that. So essentially what we need to do, plug init, which will automatically initialize the plugin and allocate the memory and stuff like that. And maybe somewhere in the plug.c we can say something like trace log, right? So if I remember correctly, so somewhere in Raylib, let me take a look at the includes, let me take a look at this kind of stuff, trace log. Is this how you do that? Where is the trace log? Yeah, there we go. So, and yeah, we have to provide trace info, I think. Is it info? I don't freaking remember. I think it's a log info. Yeah, it's a log info. And we're gonna say initialized plugin. There we go. So if we try to now run this entire thing, it's seg faulted. Fuck me, how did that happen? That is not supposed to happen. Interestingly, if I try to do that, it actually worked fine. What the fuck? Is that because of this thing? Bruh. If equal null. Yeah, that is true. if it's equal to null. Yeah, true. That is totally true. Undefined symbol plug init. Okay, that's cool. Undefined symbol plug init, which is kind of weird. Let me actually see. So if you take a look at the external symbols, there's no external symbols in here, I think. Yeah. I suppose one of the things we have to do in here, right, so when we're compiling this entire stuff, we have to explicitly say that those things are going to be external, I think, right? If I'm not mistaken, let's do something like that. I don't remember like explicitly marking them as external, but maybe this is something that we'll have to do. No, not really. So that's kind of bizarre. Right, let me see. Yeah, and it still doesn't contain the symbols. Absolutely bizarre. All right, let's go to Visualizer. Let's actually go to Visualizer and see what do we have in there. Right, so if we take a look at that kind of stuff. Right, for instance, in Visualizer, I never had to do this kind of things. So I wonder how exactly do I handle that when I'm, for instance, compiling those things. Right, so we're gonna do Noob Linux. Do I do anything special about them? Where is the compilation? Right, so when I do plug a so, I just do, I also link with all these things like LM, LD, LP thread, or something like that, but doesn't really make any freaking sense, bro. Doesn't really make any freaking sense. Okay. So plug.c. This is a wrong plug actually. Maybe I just named them incorrectly? I don't think so. Like it doesn't really export them. So let me take a look at noob.c. So int build plug. This is just shared. There's something, man, I don't know. Attribute visibility. I never used attribute visibility in Visualizer. Right. Right, so I never had to use it, so that means there's something else wrong in here, which I don't really understand. Because we can even take a look, right? So here's the symbol. So there's no plug in here, but in Visualizer, if I'm not mistaken, right? In Visualizer, if I take a look at this thing, it does contain like everything that you probably need in here, right? So plug init, and so on and so forth. So there's something bizarre in here, and I'm not really sure what exactly. Right, so let me take a look at maybe config in here. So we do enable hot reloading. Okay, so let's actually try to run Noob and take a look at the command lines that we call in here for all of these things. Yeah, so everything seems to be fine. The only thing we don't do in our application is we link with LM, DL, and P thread, but I feel like at least it never complained about it, right? It never complained explicitly that you need these kind of things. So I'm not really sure. We can just go ahead and add them, right? So, and it would be kind of weird that this is sort of like something implicitly that you have to add, otherwise it's gonna silently break, right? I really don't like this kind of situations, but I mean, it could be one of those situations, who knows? Right, you never know. So, all right, so that's kind of weird. It's kind of bizarre, I would even say. Okay, so, and that's... No. That is bizarre. PYC, maybe I'm a bit too late. But I never have to add it to Visualizer, right? So in Visualizer, let's try to run it one more time. PYC, no. So here I'm adding this entire thing, and I add that thing in there. Okay, the only difference, by the way, we have in here is that we compiling Raylib ourselves, right? So we compiling it ourselves. Is that the only reason? Is that a missing C file? You think I'm missing C file? Could be. It could be something as dumb as that. It is. Why does it allow me to compile it? Freaking C! Oh my god. Why this language is still a thing? Can anybody tell me? Freaking stupid ass C, I swear to god. Anyway. All right, so we also have assert. Thank you so much. Assert, let's go. Okay, so that seems to be fine. If I take a look at the symbols, here they are. Here are my beautiful, beautiful symbols. It even has P. Beautiful. All right, so let's take a look at this stuff. So well, I mean, it's static, so it's probably not visible. Right. Let's actually try to run it. Okay, so if I like plug in or maybe initialize, what was it called? I forgot. Plug C. Ah, we actually removed the login in here. Okay. Might as well actually, by the way, do something like this, so we can instantly see right, that we initialized the plugin. So, and in here, what we can do, right, we can enable this entire thing, right? So I wonder what exactly we want to do here. Do we want to initialize it after we loaded the window? Maybe that makes a little bit more sense. And by the way, here we probably have to call plug update. Update. That works, and it says initialize plugin, which was printed in the separate DLL. Right, so it's kind of doing some weird shit, right? Because it's using the background from here, but we never initialized this thing properly at all whatsoever. Maybe this is something that we have to do. So we can do memset p0 size of p, and let's go. So it's going to be 0 initialized. So after that, I suppose maybe we can do background is going to be green, right? So we can explicitly initialize this entire stuff, and it is green, as you can see. So it complains a couple of things because it's memset, so we're supposed to maybe put a string in there. That's fine. Let's go. So cool. We have a logic in a separate DLL. We have an event loop in a main program. So now we need to learn how to hot reload this entire thing, right? So we need to hot reload this entire thing. So thank you so much for the Beats TCP stream. So I think I didn't acknowledge some of the subs. I really apologize for that. I was slapping the code like crazy. I think I already acknowledged Sintus. Thank you so much, Astrobot, Rurinka, Koi Coder. Thank you so much for your one with the message. Ah, yes, Raylib, highly cultured stream. Yeah, it is highly cultured stream. That is true. Johnny the Rest, thank you so much for Twitch Prime with the message. This would be nice to see pre-processed. Probably, maybe. We'll see. So, Phased Plasma Rifle, thank you so much for tier 1, and TCP stream, thank you so much for 100 bitcoins. Thank you. Really appreciate all of the bitcoins. Okay, so let me see. So we need to decide what thing we're going to use in here. So I think I need to essentially separate this entire stuff to a function, right? So basically load or maybe reload libplug, right? So reload libplug. So I think this thing should be a global thing, right? So this should be a global variable, like so, and this thing should be global thing as well, right? So essentially, we're gonna move all of this stuff to that function, reload libplug. We're reloading libplug, and here's the thing: if libplug is not equal to null, first thing we have to do, we have to close that, right? So we're going to do DL close. If it's already equal to null, this is the first time we're reloading this entire thing, so we are not going to do that. So here then we're reopening and so on and so forth. So another interesting thing is that, I don't know, we just return an integer, right? And if reload plugin, might as well return 1, return false. Yeah, the other way around. And then here, in case of success, we return true, and this is going to be the boolean. So if we didn't load it successfully, we're going to just return 1. Okay, cool. So now, if the user is key pressed key R, let's use R specifically for here, right? So what we're going to do in here is simply call plug pre-reload. We're gonna save the state, right? So here we got this state of the previous thing. Then we reload the libplug and we do plug post reload and we pass the state in there and we continue as usual. So here we're generating the frames. The user pressed R. we check for that, we notify the old library that we're about to unload you, right? It gives us the state that it allocated with malloc and stuff like that. Then we reload, we kill it, and then we pass that state to the next one so it can continue generating these frames. That's basically what we're doing here. That's basically what we do. So that's the basic hot reloader, essentially. Isn't that cool? I think that's pretty cool. Anyways, so let's actually try to run this entire stuff and look at that. So can I now reload some scheisse? So for example, here is the background. What if I say the background has to be red, right? And now, yeah, so just a second, yes. Ah, fuck, shit, damn. One more time. So I probably have to run it in like this in a separate process. There we go. So then I can essentially just keep rebuilding this entire thing. Yeah, so like separately. Okay, so this is a red thing. So now I can say, okay, now I want green stuff. Now I want green stuff. Boom. Something didn't work. Okay. Let's try to figure out what exactly was wrong. Right. So as I don't fucking know, is key pressed key R? So we just do that, reload, lib, blah blah blah. What the fuck is going on, bro? What the fuck is going on? We're supposed to literally like close this entire thing. If it's not equal to null, then we just reload this entire thing. It should just work. Bruh. Bruh. I enabled all the freaking warnings and that is not enough to catch that. I'm gonna switch to Rust. I swear to God, I'm gonna fucking switch to Rust. Okay, anyway, I'm joking. I'm switching back to that shitty language. Okay, so let me see. So now I can change it to red. Right, boom. Can your Rust do that? Can your Rust do that? I don't fucking think so. I don't fucking think so. I don't need no Python. I don't need no Lua. I can do all of that shit in C. I think the time has come to make a small break. So, yeah. So now I can basically iterate on animation and stuff like that. That is very cool. That is very poggers. I think it would be also kind of nice to maybe even set FPS, set target FPS to 60, right? So it's not going crazy too much. And yeah, so we can start doing animations and everything. So afterwards, we probably need to create some sort of like a separate mode that renders the, you know, FFmpeg videos and stuff like that. So we'll see how it's gonna go. But all of that is gonna be after the break. All right, so what the fuck is this resolution? Can anybody tell me? Right, so it's supposed to be 16 by 9, right? So it should be something like this, I think. Can I do it like that? There we go. So that's a little bit better. That's a little bit too harsh, I would say. So let's actually just run it in a separate sort of thread. And let's put a different background in here. So where is the plug? The plug is here, so I think I can do something like get color, and then I just can say 181818 FF, alright, so and in here I can simply just recompile this entire thing and just reload. There we go. So that's pretty cool. The next step is probably going to be just drawing a rectangle, just draw a rectangle. And where am I going to be drawing the rectangle? So maybe at here, 100, 100. So we also have to specify the color. So let's specify the color red, like so. And there we go. We got a rectangle, which is kind of cool, isn't it? I think that's kind of cool. So the next thing, maybe we can try to animate this, that rectangle, right? So essentially, we can animate its position, right? So maybe the position is going to be interpolated from 0 to the actual width of the screen. So we can take get screen width, and we can essentially keep multiplying it by sine of the delta time. Oh my god, Emacs is going fucking crazy. Okay, so what I'm trying to do, maybe I'm going to actually factor out this kind of thing to here. So here we have a width, right? So which is the width of the screen, and also delta time, which is get frame time, like so. So then we can put things like this. So this is going to be delta time. And the problem with sine is that it's going from -1 to 1, which is not particularly convenient. So one of the things we want to do in here is add 1, which will make it go from 0 to 2. And after that, we want to kind of divide it by 2 to bring it back to, you know, from 0 to 1. So one of the things, maybe it makes sense to just like, you know, multiply it by 5 in here. So something like this. And that will make it go back and forth, so to speak, but not really. It doesn't really do anything, maybe because it's doing that super slowly. Right, so when you want to actually slow it down, how do you do that? How do you do that? Does anybody know? You multiply it, you make it bigger, or you make it slower? Right, so maybe you actually, you know, multiply it by something like this. I don't remember in which direction that happens. Oh, I'm an idiot. You're not supposed to use delta time. You're supposed to use time. Right, and it's actually possible to do that, right? So double time, and it's like get time. The amount of time since the beginning of the game, so to speak. It was a thing in Raylib, if I'm not mistaken. So it's literally get time. Yeah, so get elapsed time in seconds since init window, right? So this is probably something we want to do. Right, so, and it's double, but I want it float, right? So I want it to be float. I wonder if I can do that. So data time is not used. So and it is slowly moving, right? Which means that we're not supposed to do it like that. Right, so let me see, and it's moving actually in sort of like a sine motion. Isn't it beautiful? I think that's pretty beautiful. We can make it maybe a little bit faster. Maybe a little bit faster. Let me actually see. What if I just multiply it by 2? Right. Yeah, so that's a bit faster now. Right, a tiny bit faster. So to be fair, the window is kind of too big. I would love to maybe make it smaller. So usually I like to have like a factor in here, factor like so, and then have factor, let's say maybe this time is going to be like 50, right? But that will require like a total restart in here, so which is probably fine for me. Right, there we go. So we're going to have like a smaller window like this. All right, so, and now we can just be creative. All right, we can be creative. For example, I don't like that it overshoots in here. I really don't like it. So essentially what we want to do, we want to kind of subtract the width of this rectangle. So -100, like so. All right, and if I reload this entire thing, it is not overshooting anymore. It is not overshooting anymore. Look, no Lua, no Python, no scripting language. How is that even possible? It is possible. You don't need scripting languages for this kind of stuff. You just don't need them. So yeah, so we'll be kind of, so it would be nice to maybe separate that into like a variable of some sort, right? So rectangle width is going to be 100, rectangle width, rectangle height, right? So rectangle width, rectangle height. And here we also do rectangle width. So the reason why I want to do it like that is because now I can do something cool. I want to center this entire thing vertically, right? So somehow, essentially, I want to put it at the half of the height of the window, right? Of the screen rather. So this is going to be, something like this. So this is going to be the height. And down there, this is a half of the height. But then minus half of the height of the rectangle. So that will kind of put it at the center. So now it is going from left to right in the center. So that's pretty cool. That is pretty cool. Right. So and essentially, this is basically the kind of animation that I want to make. So essentially, the first animation in my video is going to be the demonstration of what Turing machine is, right? The demonstration of what Turing machine is, and I wanted to make a cool animation, like the tape sort of like scrolls in from right to left, right? And also the head moves from left to right, and they kind of sort of like moving with easing in and easing out, and they kind of stop at particular thing, and it's sort of like this Turing machine appears, and then I can move around and show like how Turing machine works and how it changes the state and how it substitutes the symbols and stuff like that. It's kind of like a hand wavy, right? And this is because I don't really know how exactly it's going to look like. I just need to start sort of like creating this animation, and then it will become obvious how it is going to look like. Right, so, and obviously the tape is not going to consist of a single thing, it is going to consist of several things. Right, so because of that, maybe I want to stop this entire thing maybe somewhere at 0, right? So this entire thing is going to be at 0, so it kind of stopped, right? So there we go, it kind of stopped in here. So afterwards, we probably want to have several of the cells of the tape. So let's actually do something like size ti, and let's say that I wanted 2 of them. Let's try to draw 2 of them, like so, ++i, and we're gonna just put the stuff in here. And how we're gonna be doing all of that? So it's sort of like an X position, very much depends on I. Right, so initially I multiplied by the width of the cell, right? So this is the width of the cell. So if we try to do something like this, it's basically going to create like a longer thing. Yeah, so, but you can't see that it's 2 cells. You can't really see that it's 2 cells. So you need some sort of a padding, right? So let's actually introduce something like pad, which is maybe going to be related to the width of this entire thing. So let's say that is going to be width like a 1/10 of the width, right? So because of that, we can say this one plus the padding, so that will kind of separate these 2 things, and we can actually see them, and then we can quite easily say that we want 10 of them. Very easy. So can you believe that I'm doing all of that in C? Can you fucking believe that I'm doing all of that in C? Just saying, chat, just saying. Right. So, and we can continue with this idea of sinf and stuff like that. We can just do sinf t multiplied like by 2, right? So, and let's actually map it back into this thing. So +1, right? So this is going to be +1 multiplied by 1/2, right? So, and we're going to restart this entire thing, and that didn't fucking work somehow. That's surprising, honestly. So this is because we probably want to. Yeah, we probably want to multiply this entire thing by the width of the screen, right? So, yeah, so this is the entire sort of the fuck. What's the tape doing? What's the fucking tape doing? All right, so maybe I'm gonna actually subtract this entire thing, right? So, and it's actually going into the different place. So this is the kind of thing I want to have in here, right? So maybe. Maybe the padding is going to be slightly bigger, maybe like a 15% of that. So there, as you can see, there's more stuff in here, right? And maybe I'm going to have 20 of those things as well. So now we have a tape that moves back and forth in here, sort of like this, right? So, and I really like when you use sign, it has like this easing on the ends of this entire stuff, right? Some sort of easing, which is kind of cool, right? So in terms of the color, we can actually factor out the color of this entire thing. So for example, cell color, right? So I can just put it somewhere here. So color, cell color, like so. And it's, as far as I know, there is something like color brightness, right? And I can say that I want to make this entire thing a little bit brighter, but I think it will make it darker. Oh, it's actually made it brighter. Okay, so that's cool. So that means I can do something like that. So I can modify the base color like so. I can modify the base color. All right, and maybe in here something like yellow would be better. I was kind of thinking about the yellow color. I think the yellow color was a little bit better. So yes, we got the tape. We got the tape. Interestingly, so you know, I want to be able to actually do this thing that I did in Epers, if you know what I'm talking about. The thing that I did in Epers, where I had a palette that I could modify at runtime. Right, you know what I'm talking about? Right, because it's kind of difficult to adjust. Well, maybe it's not that difficult, honestly. Yeah, maybe it's not that difficult. If I have this kind of thing where I could just tweak things around, maybe it's totally fine. Yeah, maybe it's totally fine. So, all right, so let me try to maybe put 0 in here. Right, so let's try to recompile this entire stuff and I'm just going to run it. People say that it's a little bit dizzying, so I'm going to actually stop doing that. So one of the things we can do now, if we want to adjust some colors, we can do, I think color HSV, maybe get color. I don't know, what was that HSV thingy? Does anybody remember how it was called actually? Does anybody remember? So Raylib HSV, color to HSV. No, color from HSV. That's what we want to have in here. Okay, so that's the thing we want to have. Right, so hue, as far as I know, it's from 0 to 360, so I can put 0 in here. The saturation is going to be 1, the value is going to be 1, which basically gives you the full color in here, right, which is going to be red. And now what you can do, you can modify the saturation, you can make it less saturated, like so. Right, less saturated, that's already not a bad color. And maybe it has a less value, right, which is gonna make it darker, like so. Maybe it's fine, maybe modifying the colors like that is actually rather convenient. I think it's rather convenient. Anyway, so that's cool, that's cool. All right, so we're gonna be doing it like that. So we've got a tape, that's cool. So now we need to sort of like draw the head. Draw the head that sort of reads this tape and so on and so forth, if you guys know what I'm talking about. And I'm thinking about that thing being sort of like a frame, right? It's sort of like a frame that is just put in here, right? So, and I wonder if you can draw frames in Raylib. So I can draw rectangle. There should be something like draw rectangle lines. Look at that. You can draw lines that don't fill in the inner rectangles, and I suppose we can even specify the thickness. We can specify the thickness of the lines. Okay, let's actually try to use that. So, all right, so let's put that stuff in here. So, and it requires like a legit rectangle, unfortunately. So, okay, let's go ahead and just define this thing. Right, so this is going to be something like that. So in terms of X, I think I'm going to position it at 0, 0 because I just want to experiment with this entire thing. So this is going to be width. In terms of width, let's actually make it the width of, you know, the original like cell in here. So they're going to be dependent on that. So this is going to be height or H. So, and we're just like using that. So the thickness, I don't really know. Let's put 10 in here. And this one, I'm going to put yellow, something like that. All right, so let's see if it's going to work. So it doesn't like that. What the hell is going on? I forgot a semicolon in here. Classic. Freaking mother flipping classic. And this is what we've got, chat. This is what we've got. So this is sort of like the frame I want to have. Maybe I want to have it a little bit thicker. A little bit, like a tiny bit thicker. That's exactly what I'm talking about. That's the thickness I want. That's the thickness I want. Okay, so that's pretty cool. But I want to kind of position this entire thing at the center in here. So I want it to be looking at this stuff, right? I want it to be looking at this stuff. How I can make it looking at this stuff? That's a thick boy. That's a thick boy indeed, meine Freunde. That's a thick boy indeed. All right, so I can just, you know, do the usual thing where I would say, all right, I'm gonna initialize it with 0, and maybe I can update its y after I initialize it, right? So that kind of makes sense, I think. Right, so we can say that we have the height of this thing, we're gonna divide it by 2 minus the half of the height of this thing. So that's one way to do that. That's essentially one way to do that, and something went wrong. What is the error? So it's a height. It's not called H. Sure, it's not called H. There we go. So we kind of did that. We kind of did that. So unfortunately, so in terms of X, it's fine. But I suppose if we want to, you know, make it a little bit bigger, I want it to be bigger than the cell itself. Honestly, when I'm reading this entire thing, I think I want this, the inner square, to be of the size of the cell. right, to be the size of the cell. How can I achieve that? How can I achieve that? I can only achieve that if I have the thickness as a separate variable, so I can use that, right? So let's say head thick, right? So, and let's put head thick in here like so. All right, so, and now, so maybe I'm gonna just put it like that. So essentially, in terms of width and height, I want to say that it's going to be plus head thick 2 plus head thick 2. Do you guys know why? Do you guys know why? Because I'm going to just assume that the thickness is the full thing in here. So that means I have to sort of like put it away in all of the sides. In both of the sides, left and right and top and bottom, and that's basically my assumption. That's why it's like 2. I'm not sure if it's gonna work out, but we'll see, Right, so it's actually, it kind of did work out, honestly. It actually kind of did work out. Huh, that's pretty cool. That is actually really cool. I wonder if we can try to adjust this entire thing just to see, right, how I can do all of that. Can I associate the offset of this thing with the mouse position in Raylib somehow? Get mouse I can get the mouse position. Okay, so I can essentially get the mouse position and take X, for instance. Can I do shit like that? That would have been kind of cool, right? Okay, I can actually. So, but this is so fucking funny that I can do this kind of shit so easily. So then I can do plus. Alright, so I can do plus and everything. Yeah, so it's kind of meh. But yeah, you can see what the fuck is going on here. Yeah, you can see. So they kind of do the trick. They kind of do the trick. So let's actually try maybe. So it's plus. But I also like to maybe subtract like half of the width of the screen, right? So then it doesn't look that weirdly. Yeah, there we go. So now I can sort of play with this kind of thing. You see what's going on here? You see? That's pretty cool, right? So, and I haven't really restarted the application so much yet. Right, so I haven't restarted the application, right? So like at all, like I'm doing all of that in runtime. So that's the beauty of hot reloading. And again, I'm not using any Lua, I'm not using any Python, not any dynamic languages, just a pure C. And just the mechanism that's been in operating system for decades. That's simple. All right, so what we're gonna do in here, maybe actually, I'm gonna do 4 of the thickness, so we have an extra sort of padding in here. Yeah, that is not bad, right? So you kind of have this extra thing. That is actually super cool, honestly. That is actually kind of cool. Maybe it's too much. What about 3? Right, so let's actually see. That's a little bit better. That's actually a little bit better. That's pretty epic, I think. Okay, so we are actually subtracting half of the screen. What if we subtract full screen? Yeah. So that's pretty cool. So what if I position that thing at the center in X as well? So rectangle X, width half of that, rectangle width half of that. All right, so let me freaking see if I got a semicolon. That's totally fine. That's totally fine. And somewhere at the center. Right. That looks cool. So essentially, the idea of the animation is that the tape is sort of gonna like basically appear, swoosh from right to left, and the head is also gonna sort of appear from the other side, and they're gonna meet at some point in here like that. And then after that, we're gonna be playing animation how the head sort of like steps, reads the thing, changes the state, then steps again, and so on and so forth. Right. So that's basically the idea in here. The colors suck, by the way. The colors absolutely suck. I'm gonna just adjust them and everything a little bit later, but this is sort of the base of the scene I want to have in here. And by the way, the size of these cells are independent from the size of the window, which is probably a problem, right? For instance, if I change the you know, the size of the window a little bit, like a factor, make it 100. Right, so it's gonna kind of stay the same on this. Yeah, so I think the like the actual animation is gonna like happen at this resolution, roughly at this resolution. And I'm not sure if it's gonna be dark scene, honestly. I'm actually not sure if it's gonna be dark scene. The Ghosts Don't Suck were just sponsored by McDonald's. It is McDonald's actually colors. I didn't realize that. All right. Needs more brown. I'm sorry. I actually wanted like a little bit brighter colors for the background at least. But we'll see how it goes. We'll see how it goes. Okay, so let me actually try some stuff. So where is the plugin? Where is the plugin? And what if we go back to the, you know, dizzying sign animation? How it's gonna look like? What the fuck is this? Okay. It's pretty. Right. Let's pretend you never saw that. You never saw that actually. Okay. So what I wanted to introduce, like, I want to be able to somehow customize different interpolators like that. As you can see here, I'm using time as an interpolator, right? I'm using time as an interpolator. In fact, I'm using time plus sign as an interpolator. Here, I'm using mouse as an interpolator, and so on and so forth. So essentially, I want to sort of like have a system that allows you to compose different chunks of interpolators, right? So I think I already tried to develop such system before several times. Right, and let me try to describe what exactly I mean by that. So let me think. So there should be some sort of a chunk, but I'm not sure if I'm gonna call it like that. So, and it's gonna be basically interpolated like from one value to another value, and these values are supposed to be like from 0 to 1, right? So, and then you have just like a bunch of chunks in here. Maybe I'm gonna make it a dynamic array, so something like chunks. Right, so it's going to be chunk, it's going to be items, and in here is going to be size, count, and the capacity, size, count, and the capacity, and you just like append a bunch of chunks and so on and so forth. Right, so, but this is basically the value of the interpolator that has to change from this value to this value. We also need to store the duration within which that change has to happen. Right, so I suppose we're going to store it here as well, duration. So how do you call this kind of chunks actually? All right, so how do you call this kind of chunks? Right, I'm not really sure how exactly, but yeah. So in essentially, we're going to have some sort of animation. Style, it's not a style, that's for sure. That's not style. Right, so an animation which basically stores the current value of the interpolator. Keyframes, this is not a, well, maybe it's actually keyframes, yeah. That's a good point. I think it's a keyframe. I think it's kind of like a keyframe. So let's actually rename them, okay? So keyframe. At least for now, I think it's a good name for this stuff. So, and this is keyframes. There we go. And animation, it basically stores its current value of the interpolator. Let's actually call it T, right? And maybe it's also going to store the duration of like the whole duration of the animation, or the duration of the current like keyframe that we're currently playing. So then we switch to another one, and then another one, and another one, and so on and so forth. Right, so we're gonna call it like a duration, something like this, something like this. Okay, so, and essentially I want to have a function that updates animation updates animation. It accepts the animation by a pointer because it's going to be modifying it. And I suppose it's going to accept the keyframes in here. So I could have accepted, yeah, I can just accept this entire thing like this. I'm going to call it KF. Yeah, that's cool. So also the animation should keep track of the index of the keyframe it is currently playing, right? So that's one of the things it has to do. Right, so let's actually put like size t in here, like index, maybe I, let's call it I think that's fine. Right, so and essentially, how we're going to be updating this entire stuff. So we do have the delta time. So let's put a delta time, get frame time like so. And essentially, we know that we're currently playing this frame, right? So I is an index of the keyframe that we're currently playing, right? So we know the duration of this thing that we have to play. We know the duration. And also, as we update this entire thing, we probably have to update our own duration here. Something like this, plus dt. So I suppose we're switching the frame. When the duration of the animation, right, became greater or equal to the duration of the current keyframe. So that's the sign for us to switch to sort of the next keyframe and stuff like that. So by the way, because of that, since we know the duration, the current duration of the animation and duration of this thing, we don't really need to keep track of the t because we can just compute it, right? So if you want to know the current interpolator and stuff like that, what you do is just simply, you know, take that, divide by that, and you have a value from 0 to 1, and you simply interpolate, right? You simply interpolate from this thing, like from to this thing. Very simple formula. Very simple formula. Almost. I know it's funny. Anyway, so we can actually simplify all of that formula if we factor out this kind of thing. Right, so let me actually put it a little bit here. We can always factor out to something like this. So I think it would make sense to actually call it KFS, almost like KFC, but it's actually KFS. Right, so and in here we just replace this with KF. It's the current frame, so to speak. Right, and essentially we just do keyframe, KF is going to be a pointer, and we're just taking that specific pointer. But it's a little bit dangerous in the sense that I can overflow the amount of keyframes we have in here. So I suppose one of the things we need to do, we need to check that this thing is less than the amount of frames we have in here. So I don't really know why I like dereference it in here. It doesn't really matter. The compiler will tell me that something is wrong here anyway, so it doesn't matter. Right. So, and that kind of simplifies, right? So, like so. So we make sure that the animation currently playing with the right keyframe. So we then take a pointer to that keyframe, and now we don't have to write this huge expression and stuff like that, which is rather convenient, I think. I think it is rather convenient. Anyways, so, and then the actual interpolator for animations and shit like that can be computed like this, right? Can be computed like this. So we can even factor that out to a separate function, sort of like, you know, animation, you know, interpolator, which is a huge freaking name, but I mean, what else can I say here? Oh, by the way, it has to be dereferenced. Whatever, the compiler will tell me that I'm doing something wrong. It doesn't matter. All right. So I can just move this entire thing to here. And the funny thing is that we have to check whether we're overflowing the keyframes again. Right, we have to check that we're overflowing these things again. So because of that, I think I'm going to implement that a little bit later because I don't want to be dealing with this stuff right now. Anyways, so what we're doing, what we have to do in here is essentially we have to switch to the next frame, right? Switch to the next frame, And we have to kind of update the duration, right? So we have to sort of say, okay, subtract the duration. So if there is a little bit of overshooting, to the next keyframe, we want to kind of keep that remainder in there. But what if the delta time overshooted over several keyframes? So that means we have to do that in a loop, right? So while duration is bigger than the current like keyframe that we have in here, we have to sort of like keep updating this entire thing. So we do +1, and we also have to actually say that so while it's greater and sort of like the next one is still less than whatever keyframes we have in here, we have to keep updating this entire stuff, like keep updating and so on and so forth. And I suppose, right, we have to also reassign this entire thing, right, because we're currently referring to this thing. So that's basically what we're doing, this entire stuff. Right, so this is basically how we're doing all this entire stuff. Until we sort of like reach the animation. So okay, that's a pretty simple way to do that. It's a very simple way to do that. Okay, let me see if it compiles or not. Yes. So this is this has to be like that. What else do we have in here? So yeah, so that compiles. So and essentially what I can do now, what I can do with this kind of stuff now, I can do pretty cool things, I think. I can define a bunch of keyframes in here, right? So for instance, I can have keyframes, KFS, and it's initially going to be 0, and then I can just append a bunch of things. So it's Noob, di append, KFS, and this is going to be chunk. To be fair, you know what? I can define this stuff like just like this, and then just define them. Yeah, so that's even better. And then I can say, okay, so I want to move the interpolator from 0 to 1, during like 1 second. During 1 second. So that's the first thing I want to do. Then I can say, all right, so then I move from 1 to 0, during, let's say 250 milliseconds. And I can stack these chunks on top of each other. And this is sort of like the keyframes that I have in here. So that's basically like how I can animate things now. Right. So because I want to be able to use the static arrays and stuff like that, I think it makes sense for me to not like even have dynamic array in here. Right. So it would be better to just like literally accept this kind of thing like this, and then maybe have KFS count like so. So let's actually go to the compilation errors and see what it's going to say. So this is going to be just a count. This is just KFS like so, and KFS. Can you see shed in here? I think you should be able to see the shed in here. So this is just a KFS, and yeah, there we go. So that seems to be cool. All right. So now I can create an animation, right? So let's call it A. And it's going to be just 0 like so. So in animation, we have just I and duration and so on and so forth. All right, so now every frame, so to speak, I'm doing update animation A, KFS, and then I need to take the size of this array. So it's going to be Noob array len KFS, right? So that's pretty cool, I think. So since we're going to be updating this entire stuff, so we can actually do it like that. So now, look. So what's cool is that animation just now within given like period of time contains these values depending on what current keyframe we're playing. So yeah, well, maybe I'm going to even create an editor that will allow me to sort of like visually modify these things. So I can adjust animation and everything and maybe save them to a separate file and stuff like that. So it's going to be like an animation editor, like in an engine, or so to speak. But in an engine, you have like an actual editor. Here you can modify it in the code, but developing such editor for nodes is going to be actually a pretty trivial thing. So we'll see how it goes. We'll see how it goes. The thing I need in here, again, I need to get the interpolator somehow, right? So it's going to be animation what's going to be the thing? So maybe value, right? So maybe some sort of like a value. And in here, we just accept this kind of thing. And we also need to accept the keyframes because this is where we're getting all of that stuff from. This is where we're getting all that stuff from. So interestingly, so there could be a situation when we have this kind of thing, right? So when we overflown this stuff, so it has to be actually greater. So if AI, by the way, right? So AI is greater or equal than the amount of keyframes we have in here, we can simply return, as of right now, like the last thing in here. So it's green count -1, 2, right? We're literally returning the last possible value because the animation sort of overshoot everything in here, so we don't really care. Anyway, so now, once we have I, we can take the current keyframe, right? So pretty safely, and then simply compute the following thing: the duration divided by key f duration. So this is a value from 0 to 1. So, and in here we can just interpolate. So in Raylib, I think there was an interpolator, right? So there was a lerp. Yeah, so this is what we need in here. So the start is going to be kf from, the end is going to be kf2, and the amount is basically this relationship, and we simply return this entire stuff. Right, look at that. So this is animation value. Maybe I'm going to call it animation update. Yep. I'm sorry. So animation update. So now we're updating this entire stuff every frame, right? So we're updating this entire stuff every frame, and then we probably need to get the value of this entire thing. So let's call it T, animation value. I'm just passing this stuff like that, right? And now I can use this T instead of this nasty synth. Right, so I can use this T instead of this nasty synth, and look what is going to fucking happen, mate. It's not gonna even fucking compile because we already have the T. Okay, so there's a couple of things here. Let's go through the compilation errors. Okay, so lerp, we need to include math. What else do we have in here? KF, yeah, all of that is a pointer. That is understandable. What else do we have in here? So we have this kind of shit. So this is T, which is redefinition. We don't need this shit anymore. Okay, so we don't have Noob array. So let's include Noob here as well. I think it's going to be useful within this entire stuff. Noob is not found. Now it is found. Everyone is freaking happy. Let's remove that shit. Nobody needs that. Cool. Everything compiles. Now, look at that shit. So we have two keyframes. Move the value from 0 to 1 within a single second. After that, move the value from 1 to 0 within 250 milliseconds. What is it going to be? Right? If you think about it, it's like 1 second, you rising up 1 second, and then you fall in for quarter of the second. Make sense? Makes sense. Okay, let's reload that. Shit didn't work. Okay, that's very interesting. I think I know why. Because this thing, yeah, it's understandable. Because it's reset on each individual frame. We need to make it survive between the frames. Right, so we need to make it survive between the frames, and one way to do that is to actually move it into the plug state. But there is an easier way to do that. You can actually declare it as a static, which doesn't require restarting the whole application, but then it's gonna reset this entire state on each update. So there is like this kind of stuff. So you want to keep stuff in the plugin state only for the things that you want to survive between reloads, which in our case is not really that important, honestly. We're not like making a complicated game that is very difficult to get it into a particular state. Or do we? I don't really know. We'll see. Maybe at some point I will realize that like having this kind of like persistent state between reload is kind of an overkill. But we'll see. So did my application crash or something? It's motherfucker crash, I think. Anyway. Did you see that? So, and that's the point of these keyframes. Now I can stack this entire stuff on top of each other, right? So now I can say, like, for example, from 0 to 250 within, I don't know, within also maybe like a quarter of the second. Then we can basically stay in that value for this amount of time, right? And then we can move super quickly, maybe move slowly, like from that value to 1 for this amount of time. So I can now control these kind of things. I can now control this kind of things, which is actually exactly what I want. Right. So maybe we also want to sort of loop this kind of animations, right? Sort of like loop this kind of animations. Maybe we're gonna introduce something like loop. And what is it going to do is when you reached this state, if AI is greater or equal than KFC count, right? So what you want to do, you want to basically mem set this entire thing to 0, like so. So it will repeat itself. Why am I? And we only want to do that if we are looping, I suppose, right? So a looping, if a looping, and that we're gonna do that. Like I'm surprised that it didn't happen, so that's kind of interesting. So looping is true. Because it was in animation update. Well, I mean, it is an animation update, so what's up with that? It's not an, yeah, it's actually loop, not looping. Right, and this is just loop. Okay. So I expect this thing to work. So that's kind of bizarre, isn't it? Hey. Why didn't it work? Excuse me? That's bizarre, my friend. That's bizarre. What the fuck is going on? So maybe it didn't update it properly, like especially if you have static. Ooh, fuck. These static initializers are probably done in special, like, init functions of this thing. Right, because I know that according to ELF, you have shit like underscore init and so on and so forth. And these initializations of like static fields and stuff like that are probably done in these things. I think, maybe, because I kind of had a similar problem in Visualizer too. I kind of had a similar problem in Visualizer too. So that's actually kind of cool. All right, so I want to Google it up honestly because it's kind of fascinating. Like, does anybody know? Does anybody know like where all of these things are initialized? Right, so init function of SO. Maybe we can ask ChatGPT to confabulate some shit. Executing init and fini. Oh, okay, we have some real humans speaking on Stack Overflow. Yeah, so I just read init and fini sections in ELF files and give it a try. So I do blah blah blah. Result is there any official documentation about init fini? Don't do that. Let your compiler and linker fill in those sections as they see fit. You are too damn for this kind of shit. Let the smarter people than you figure it out. Fucking, I hate answers like that. Like, Jesus fucking Christ. This is why, by the way, people like ChatGPT more than answers on Stack Overflow, because of people like this. And you're too fucking dumb, you don't do that. Compiler is smarter than you. Fucking, hate it. Fucking hate it. So yeah, probably we can just try to maybe like literally try to call this function. I don't fucking know, but yeah, so we'll see. By the way, so maybe this thing is still useful for some other stuff. Yeah, so we can try to just like load them up like this. Right, just try to load them up like this. Okay, so we can put this kind of stuff in here. So it's gonna be void init, And like maybe I'm doing something incorrect. Maybe these particular functions have like different signature. Maybe they accept something, and doing it like that is dangerous. And I should actually rely on the compiler because I'm too dumb for that. But I don't fucking care. If it's incorrect and it will fail, I want it to fail so I can learn something new, right? I want to learn something new. I want this thing to slap me in the face, right? I'm not afraid of that. I'm pretty sure this person who said stuff like that, they are afraid of the compiler slapping them in the face. But I'm not. I'm fucking not. I'm brave like that. So I'm gonna just go ahead, load that shit up, and fucking call it. And fucking call it. And these Stack Overflow answerers won't be able to stop me. They won't be able to stop me. They will be screaming. They will be sending me death threats in emails. But I'm gonna do that nonetheless. That's right. That's fucking right. Because that's how it's done. That's how you learn things. By getting slapped in the face. Anyways. What we need to do in here. Right. So let me see. So this is gonna be just like init. And I wonder, maybe it's gonna actually collide with whatever symbol init that we have in the program, which is fine. I want to get slapped in the face. That's the point. I want to get slapped in the face. Right, so we initialize this thing, so we probably need to do init. And I wonder if after reloading, I basically want to call it again one more time. Right, so let's see. So I'm going to try to reload this entire thing. And yeah, so multiple definitions of init. Okay, so there we go. So what we want to do actually is to have, so we already have a plug init. So let's call it plug elf init. Right, so it's going to be something like that. So it's going to be plug elf init. Right, and we're going to do plug elf init, plug elf init. And in here, we're going to say plug elf init. Right, but we're still going to be referring to underscore init in here. That's kind of the point. There we go. So if I try to run that, undefined symbol init. That's very interesting, actually. So it's not exported per se. There we go. That's exactly what I'm talking about. We fucking learned something. So I suppose it's kind of like a private, so it's not really exposed to us, which is rather interesting. But can I now do something very fucking kinky, like extern, right, like this? Can I do something kinky like that? And will it actually export that shit? That's a very interesting question. Like, I'm really curious. Like, I want to learn. I want to fucking learn. You won't be able to stop me. A random Stack Overflow answer, you won't be able to stop me. I'm on my way to learn shit. I'm on my way to learn shit. I'm unstoppable. All right. So let me see what we have in here. So it's gonna be this, and let me see. So init. It's still small t, which I'm not really sure if that affects the visibility or something like that. Right, so let me now try to run this entire thing. Okay, so I still can't load it. Okay, I give up. You won, random Stack Overflow answer this time. But, I mean, I learned some things, right? So I think it was kind of like educational to fuck around, just try these different ideas and stuff like that. And my hypothesis, again, is that all of these initializations are done within one of these initializers, right? And my job is to basically call it somehow, but I'm not really sure how exactly I'm going to call that. So yeah, we'll see. So okay, so since I restarted the application anyway, I might as well actually just simply put that animation to the plugin in here, right? So I can do it like that. Who said I can't do that? I can fucking do that. All right, so and when we initialize this entire thing, I can say, so we already zero initialize this entire stuff, so we can do PA loop, and it's gonna be true. So the definition of the animation is probably somewhere there. So we probably want to make it here, so it is visible for the plug. Let's try to recompile this entire stuff. So we have A, so we have to do something like this. What else do we have in here? PA, looking good, so we don't need that. Wait a freaking second. So I had a fucky-wucky situation. I literally had a fucky-wucky situation. Let's go back. Let's go fucking back. Right, so I was assigning alpha, but I was checking the thing that was already null. I literally had a fucky-wucky situation, so maybe we can still save that. We can probably still fucking save that. All right, so let's actually go back and define the animation inside, like in the static memory in here. Right, so we're going back into the static realm. Okay, that's cool. So, and in a plug .h, we're bringing this thing back. So we brought this thing back, we brought this thing back, and in main here, we brought this thing back. Okay, so that's pretty cool. So we're initializing that. We also need to, yeah, so we also call in all of that stuff in here. Okay, so, all right, all of that compiles, and if I try to run that, it still fails, okay? Right, it still can't find that symbol, right, despite us actually properly checking things, right? And I do think we actually properly check these things like this time, right? Because you can see. All right, okay, so enough of that, enough of that. Right, so we're just trying to learn things, nothing more, nothing else. All right, so let's bring all of that stuff in here, like so, boom, boom. And where is the definition of the animation? Animation, like so, boom, and let's go to the computation errors, I suppose. Well, in plug init, what do we want to do? I want to do PA, and I want to make it loop, like so. Let's try to compile. All right, so A, PA, anything else? The second one, PA, anything else? Okay, something else in here. We don't have this function. What else? We don't have that function. Okay, that's cool. It doesn't loop. Doesn't motherfucking loop. I have no idea why. Right, so because I would expect it to do that. Oof, I think I know what kind of stuff I can do. I think I know. Maybe we have to do it in here. Right, so essentially, if, yeah, so we went to overflow in here. So we're doing a kind of a weird check, honestly. We're kind of doing a weird check. So we first have to check that we are within that stuff. Right, we are within that stuff. And then I suppose we have to do probably KF. So this time is kind of easy, right? So maybe I should get rid of this thing. Yeah, I should get rid of this thing. It's not helping anybody. So while we are at here, and we are at here, we're just incrementing this thing and we're subtracting, you know, the duration from here. So we have to be actually subtracting the duration from here. So we are greater than that. We subtract that duration that overflow and we just go to the next one until we completely overflow the keyframes. And if we are in here, and if we are looping, right, we are looping, we just memset. I see, one single memset. Okay, this is so dumb. I swear to God. That memset also sets loop to false, which means it actually not looping anymore. So that's basically so freaking dumb. All right, so this is going to be 0, right, and this is going to be duration also 0. All right, so something like this. This is what we want. Right, if we overflow and we are looping, we're just going back, right? We're just going back, we're trying that. But this one is kind of weird, because what if KFS is equal to 0 and we're looping? This one is going to be really weird, honestly. This one is going to be really weird for this kind of situation. Right, how we're going to even do that? We're going to kind of assert maybe. Assert that KFS count is greater than 0, at least for now, and I'm going to try to figure out a little bit later. All right, so honestly, I'm gonna assert that on all of them, right? So we kind of expect you to have at least one thing, right? So it's just like, yeah, that makes sense. All right, so let's try to now do this kind of thing. Is it going to work? And this one is the duration, which is understandable. Yeah, okay, so now it's looping. Yeah, almost. Kind of makes sense, but there's like 3. So it waits for a little bit on one thing, and I can't feel that it is waiting. Yeah, that's bizarre. That's actually bizarre. How it is not really waiting properly. So this is the duration. While this thing and duration is greater or equal than the current duration, we subtracting the current and go to the next one. Goes too far. That's totally fine. That's totally fine. Yeah. But I mean, that's okay. So for the, if I do loop actually equal to false, if I do loop actually equal to false, yeah, that's fine. And then it just stops. Yeah, that's bizarre. But I mean, that's fine. So we have a system of keyframes and we now can do something with them. So one of the another things I want to do at some point is an ability to interpolate like is in and is out things, right, with different like functions and stuff like that. So easing, yeah, so this kind of stuff. So we can just add, so this is a really cool website. I really recommend to check it out. Right, we can add some sort of like a parameter which says what kind of easing function to use in here. Right, and stuff like that. In the future, I also plan to have a Bezier curves, right? So we're gonna do a Bezier curve stream. So we already kind of did it before, but I want to do it one more time. So let me go to the description and stuff like that. But yeah, so I think this is a great start. So this is going to be the base for the animation framework. All right. So, and yeah, I'm going to be using it to making animations for the main video. So, but I guess that's it for today, right? At least for now, right? Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreational programming session with Mr. Azuz. Love you.